So thank you for joining and welcome to our talk, Top 10 Tips to Speed Up Your Site. My name is Tobias. I'm engineering manager at Adobe and in the industry since more than 20 years, working with front-end, back-end, and cloud technologies. With me is my dear colleague, Francisco.
Hello, everybody. My name is Francisco Chicharro Sanz, working in the software industry for 20 years, the last 9 of them as an Adobe employee. My current role at Adobe is software engineer. Tobias and I, we are both part of the EM Sites team, and our focus is performance in the context of personalized web experiences and experimentation. Today, we are happy to have with us Mary Blanchet from our team answering your questions in the chat.
By end of the session, you have a good understanding about why speed matters and why the industry is talking in acronyms like LCP, FID, and CLS, and how it relates to each other. You will learn about our top recommendations to speed up your site, and you're going to enjoy a live demo. With all the challenges of a live demo, we even made sure to depend on an external, non-deterministic dependency for maximum risk. And of course, in order to follow the mantra of the Developer Live conference, a lot of the items on our top 10 list apply to headless scenarios. But before we start, I'd like to clarify a bit about terminology and give an holistic view on the improvement areas and give insights on how we tested the speed in the context of this presentation so that we are all on the same page. Okay, so why do fast websites matter in the first place? It's all about the first impression for a visitor. And visitors don't want to wait. According to research, about 50% of people don't wait for more than 2 seconds for a web page to load and then just move on. And in the worst case, might not return. Another important point is visual stability. It's simply distracting if the layout of the viewport changes multiple times. The layout can change because images take longer to load, while you're already focused on a text paragraph and in the middle of reading, and suddenly the page starts to jump or scroll without your explicit interaction. That impacts the overall performance of your site. And then there's dwell time. It's the time a visitor spends on the web page. And that's crucial for the success of a page. It's crucial for the potential conversion rate in commerce, and it's crucial for SEO, so the search engine optimization. Search engines know exactly when a visitor clicks on a search result and when the visitor comes back to the search result. The delta of the two is the dwell time in this context. The more a visitor spends on your page before going back to the search engine results, the more is your page relevant to the search term. So here's one example from Vodafone, where A/B testing revealed that a performant web page can increase sales by 8%. How did they test? They took an existing web page, duplicated it, and improved the performance of just one of the pages following Core Web Vitals. And I will explain the term in a bit. Then they split the traffic to both pages by 50 and measured success rate. The page that followed Core Web Vitals has been the clear winner. So, fast sites matter, and the business impact of fast sites is real and measurable. Coming to Core Web Vitals, it's a term coined by Google and shall provide guidance to site owners and help to increase the overall performance of your site, even if you're not a performance guru. So simply following Core Web Vitals will make your site more attractive to users and increase the conversion rate. The following key factors do have the most impact on your site's performance. So there's LCD, the largest contentful paint, which measures how fast the most critical content of a page loads. Then FID, first input delay, which measures interaction delay. And CLS, cumulative layout shift, what I mentioned before, which mentions layout stability or how smooth a page load is. Okay, so we learned that page speed and page performance are an essential part of the user experience. Now let's have an holistic view on the areas where you, as a developer, can influence and increase web performance and speed. Let's start from the left, the client. This is the browser where your site is running. It can be a mobile app or IT app that is running in your fridge or digital signage device. It has the responsibility to load all content and assets and to render the experience. Usually the client offers local caching and database capabilities, which is by far the fastest delivery method, especially if the experience doesn't require a network connection. In the middle, between client and origin, is the edge, a globally distributed network of servers, preferably very close to the client or your database, in order to reduce latency, and is highly optimized to deliver cached content and assets fast. You will hear the term CDN interchangeably. Nowadays, edge providers allow you to even execute code, which is usually referred to as edge compute. Last but not least, on the right side, the origin. What I usually refer to as the backend server. In AM Headful speak, AM Publish is used for data and content hosting. In AM Headless speak, AM Publish is just used for hosting the data. It's the place where the single source of truth of data and content is. It's usually the computational heavy component in the big picture. We know that you want to choose the delivery method depending on your use case. Performance is not a tool, and you always need the freedom to choose the option. There are good reasons why you want to deliver a page or a fraction of the page from origin, edge, or from the cache in the client. For the rest of the presentation, we won't dig deeper into the use cases, but instead focus on the practical steps to speed up your site. Okay, so now we have an holistic view on the areas where you can improve performance. But before we start with the demo, let's clarify how we test and measure. For the purpose of this presentation, we used Page Speed Insights, a convenient web tool to measure Core Web Vitals. This tool mixes real user and simulated lab data to measure page speed and performance and returns a score, where 100 is the best score you can have. That score will change every time you repeat the test because it's based on real user data, which has been collected from the past, 30 days. And also it uses multiple devices and clients and network connection methods. And hence, the measurement is non-deterministic. In your daily development routines, you probably are more used to the deterministic testing methods in order to compare the results. The deterministic version of Core Web Vitals is Lighthouse. Lighthouse does not take real user data into account. So here's a rule of thumb for testing. First, test locally with Lighthouse in your browser DevTools. Second, before you enable your feature to the visitor, deploy your page into production and test again with Lighthouse in order to see the effect of DNS, caching, and network aspects. Your first contentful paint will definitely change, probably negatively, and then you have to improve a few things. After enabling the feature to the visitor, start measuring the visitor's experience. How fast can a visitor interact? When is the first contentful paint for a visitor from a completely different region? What is the interaction to next paint, INP in Core Web Vitals speak? This is called real user monitoring. And you will again see how the score goes down and you have to improve things. So this is why we have this presentation today. Let's focus on the top 10 things you can improve in order to see a positive effect on the score. I think we should be good now with terminology, the reasons why we are here and how we test. With that, let's start with the demo.
Thank you very much, Tobias, for introducing the topic, for the clear explanation, and for highlighting the importance of performance in modern websites. Now let's go with the demo. But you know, Tobias, it's already a bit late in the evening in Europe, and I was thinking about how to make the demo a bit more entertaining to keep the audience attentive.
Yeah, nice idea. What do you have in mind?
I propose we play a little game. You know that I'm a big fan of the movie Back to the Future. So what if we do it were a real life situation that happens in 2 weeks from now? We will be two different people, for example, two friends that have a small agency specialized in AIM implementations. These two friends were attending this very same session as part of the audience, and they would apply what they learned in this session, the top 10 tips to improve the performance of a website.
Back to the Future. Okay, sounds cool to me. Let's give it a try.
Well, I hope you all hear that. Tobias said, let's give it a try, and he's the manager. I love it. Now, if this is a complete disaster, it's not just my fault. So let's prepare our trip to the future. So let's set our destination time to 2 weeks from now and accelerate to 88 miles per hour.
May I ask why 88 miles per hour?
Come on, you haven't watched the movie? It's a quote. Doc says, now if my calculations are correct, when this baby hits 88 miles per hour, you are going to see some, and I think I will stop here. And if you still don't know how it ends, better Google for it. So we arrived to our destination time and our destination characters.
Okay, let me put my demo hat on. Hey, Francisco.
Hi, Tobias. Good morning. How are you doing today?
Hey, I got a call yesterday from a customer asking to take a look at their website because users say it's too slow. The website is implemented as a React app, consuming content from AEM in a headless manner.
Okay, let's take a look. I think it's the one that you sent me by email this morning, right?
Yeah.
So I have it here. Sounds familiar somehow, this website. Okay, I took the advantage of running the performance check, and you see it is not so good. Actually, it is pretty slow.
Oh, okay. So what do we do?
Well, you know, we are actually very lucky because do you remember that a few weeks ago there was a super cool session about improving website performance in the Adobe Developers Live conference?
Oh, yes. You mean the top 10 tips to speed up your site? The one presented by that guy with the Spanish accent and the German dude?
Exactly that one. Exactly that one. Funny. A German guy and a Spanish. So they probably were presenting from Mallorca or somewhere nearby. So we can use the top 10 they described in the session and try to improve the performance for this customer.
That's a great idea. Actually, I remember images were a hot topic. Can you check what kind of images are used in a website?
Sure. So we have them here. You see, they are actually JPEGs, and they are coming directly from AEM. Yeah. If I remember correctly, it is better to use next generation formats and serve them from a CDN instead of from AEM directly.
Okay. Well, actually, the customer told me they have Adobe Dynamic Media with smart imaging. So they could just use it now
Oh,
to
that's
deliver.
great. Of
Yeah.
course, that's perfect fit for this. So let's try. Let's look into the code. And I think the images should be loaded somewhere here. Okay. Yeah, you see here. Okay, they are getting the image URL, and the image URL is getting from this method. So let's check what is in here. You see image URL when they actually already have the method to deliver from Dynamic Media. So let's give it a try and see how it works. We replace this one by this one. Done.
Hey, did you notice that images are not responsive and not lazy loaded? This is also important.
Oh yes, you're right. This is, you know, if I remember correctly, in the session they mentioned that the images that are above the fold, so the ones that are in the initial viewport, should be loaded with high priority, and the ones that are below the fold, so not immediately visible when the user accesses the website, should be loaded in a lazy mode. So I think we can try that. Okay, so let me see. Okay, in this case, I think the only image that is actually displayed above the fold is the first one. So what we can do is we can just say that any image that is not the first one will be lazy loaded, and the ones that are the first one will be actually loaded in an eager mode, which is the default, but with high priority. And now we add this to the image element. And you also mentioned the responsive. They are not responsive, and you are right. So let's add this as well. So we add, okay, let's make the code a bit nicer. And yeah, I think this is it. You also mentioned, if I remember correctly, that the user was, the customer was consuming content from AEM in a headless manner. So they're probably using the GraphQL API.
Yeah, in the session, they recommended to use persisted GraphQL queries with GET requests.
Okay, so yeah, I see. No, this is the call probably, right? So let's see what comes in the response. Yeah. So this is all the information coming from AEM, and this is a post request. And yeah, they are sending the request payload. They are sending the whole query. This is not so good. They should be using a GET request with a persisted GraphQL query. You know why? Because GET requests are cacheable, and post request, this post request is not cacheable by the CDN. So, and by the way, this is going directly to AEM, and this is also not so good. It could be better because, you know, this is a cross-origin request. So if we will do this or proxy through our applications, it will hit that. It will not be a cross-origin, and this is less expensive than the way it is now. So let's change that in the code. Okay. So persisted queries, yes, get all adventure. So this is what they are running right now. They are using the AEM headless client, so the API provided by Adobe. That's great, but they are calling their one query method, you know, and this method is just executing the query as a post request. So better, let's comment this part of the code, and we use this one. You see, so this one is actually executing a persisted query that is already available. And yeah, we talk about the cross origin. So let's see if we can get rid of that. This should be somewhere here. Yeah, you see the service URL. So yeah, let's use, instead of this one, the service URL. Let's execute the query directly against our application, which is already prepared for with a proxy to AEM. And I think we can deploy.
Okay, deployment and testing probably takes a bit. So while we are waiting, can you explain a bit more about that cross-origin request and proxy?
Yeah, sure. So let me first open a new tab. Okay, deployment should be not yet over. Okay, so you see here we have this post request, which is running the query, right? Running the GraphQL query. And you see, it says here, the method is post plus preflight. This preflight is a preflight request that you can see here that is sent automatically by the browser. And yeah, what it does, it is just checking if this domain is allowed by the server, the destination server in this case, to execute the query, to execute this request. So first, it sends this options request, checks the headers. If the header says that the request can be executed, it's granted, then it will execute the real post request. And you see, this took 459 milliseconds, so half a second, which is actually a lot in terms of performance. So if we will do the request just directly or proxy through our application, we will get rid of these 459 seconds. Now let's see if we have our changes already in the page.
Yeah, looking forward.
Okay, so you see, yeah, images, yeah, great. So they are being loaded directly from Dynamic Media. They are WebP or IBIF, great. And what else? Yeah, so this is the GraphQL query. You see it is using the persisted one, and the response is the data that we need, which is great. So let's now run the performance again and see where we are. This might take a while, but yeah, let's be a bit patient. Do you know, in the session, they also mentioned something about the way JavaScript should be loaded.
Yeah, they said to load JavaScript asynchronously. Oh, wow. This is already
Whoa,
93.
it was from 68 to 93. Whoa, that's actually very good. So yeah, we were talking. Yeah, sorry to interrupt you. We were talking about the JavaScript, about the way JavaScript should be loaded. So
yeah, first of all, I think we are making good progress here. But yes, they said to load JavaScript asynchronously when it's possible. So I asked the customer, and he told me that they're using Tag Manager from Adobe because they plan to use Adobe Target and Analytics. Can you check how this script is loaded in the website?
yeah, let's check that. Okay. So this should be in the head, hopefully. And yeah, we have it here. So you see, this is loaded in a synchronous manner. So basically what it is doing, this is just blocking the rendering of the website until this full JavaScript is loaded.
Yeah, and look,
let's
they're
change
also
it.
loading. They're also loading jQuery, but do they actually use it? Because I'm not sure.
I think I'm
I
sure
would
they
say,
are not using jQuery.
Yeah, let's remove it.
Okay, so let's go back to the code, and yeah, so this is here. Okay, let's add async attribute. So, and you said that we should remove jQuery. Yeah, I agree with you. So let's get rid of this. Okay, and yeah, you see, oh, they are loading the fonts here. You see that? They were in the session, they said something about the fonts, something like preload them or something like that. Do you remember?
Yeah, they said fonts should be preloaded.
Ah, I see. Yeah, but I think it was a bit more because there was something about the font display, and so you know what the problem is really is that this request here is just expensive because it is going through a different domain, Google APIs, and this is just executing some JavaScript probably. So let's do it. Let's call it in a browser tab and see what it brings. And you see this is, oh, it's a bit small, right? Maybe you didn't see it. Well, I cannot zoom in. Okay, but you see this is bringing a lot of fonts that actually are not needed because these guys, they are just need the Latin. So you know what?
Yeah.
What we can do is we can just replace this call by the fonts that we are interested in. So let's do that. So with this, we got rid of this first call to the fonts Google API, which is pretty expensive. And yeah, but you know, this still is loading the fonts from Google, which is fine, but you know, we could speed it up if we preload them. So let's do that. Okay, so here, for instance, so we have these two links that will preload in background the fonts. And then let's make sure that we are using font display swap. Yeah. So basically, these two fonts will be downloaded in background, and when they are ready, the browser will swap the fallback font to this one.
That's pretty cool. So you reduce the amount of data that the web page needs to load. Can we do something similar for the CSS?
Okay, let's check what we have in the CSS. Oh, I see they are using just a CSS containing the whole styles of the website. Yeah, this can also be improved, because same as with the fonts and with the images, actually we should allow the browser we should give the browser only the information that is needed to render the first part of the page. And this is loading the whole website. So maybe the style for the whole website. So most likely some of them are not needed. So let's do something. Since we are using React, we can change, and instead of using this kind of CSS, we can say that each component will use its own CSS file. Okay, and we just need to find the component and import its CSS. Okay, so let's do here with the adventures page. We will do the same with adventure details. Okay, and finally with the main, which is the app. Okay, here we are. Okay.
Yeah, okay,
so I
then
think,
let's deploy.
Okay.
Curious to see the Lighthouse score.
Let me just double check if I remove the CSS. No, I didn't. Okay, then we will be loading twice the styles. So now I think we are ready to deploy.
Okay, so this is non-deterministic. So potentially the score could also go down, right?
Yeah, it's with this page speed and size tool, it's a bit tricky because sometimes you get very weird results and you don't know why. So it's better to run it different times until you get something that is reasonable, right? That's something that is in the expectations that you had when you were running the test.
Yeah,
Let's
I also
see
heard to run it multiple times and then take the average.
Yeah, that's a good approach actually. Okay, so now if the deployment was successful, we should see already our changes. So same as before, let's check in the head of the page if we are loading this in an asynchronous manner. Yeah, so we have it here. Assets DM is loaded synchronously, and we don't have the jQuery. So perfect. Now let's run Lighthouse scoring.
For me, the magic threshold is like 95. Let's see where we are.
Whoa,
Wow.
98. That's
okay.
Cool.
Yeah, that's perfect. But here's the question. Do you think if the customer would use a different JavaScript framework, they will be able to reach a score of 100%?
Well, maybe with React you can also get it, but it's of course more complicated. Why? Because React is client-side rendered. What does it mean in this use case? In this specific use case, what happens is that the browser is doing a request for the index HTML page. You see this first one, and this HTML is downloaded from the server and parsed by the browser. At some point, there is a script, a JavaScript, that contains all the logic. So it is doing a new request to the server to get this JavaScript, which is actually this main.js. Now, when this main.js is back in the browser, it is executed, and then somewhere in between in this JavaScript, there is an instruction that says that we should execute a query to AM, a GraphQL query, to get the data that we want to show, and this is this one here. Okay, and then we get the JSON, and finally this JSON has to be parsed by the browser again and transformed into HTML elements. As you can see, there are many back and forths between the browser and the server. And of course, if we would be using a different JavaScript framework that allows static site generation, such as Next.js or Gatsby, then what you will have is that this very first calls index.html will actually contain all the data, including all the HTML elements and so on. So you don't need to download the JavaScript, you don't need to do the query to AEM to get the data, you don't need to parse the JSON, because all of this is done at build time. And of course, you can imagine that this is much faster than React, or that not React itself, but client-side rendering in general.
Hey, thank you very much. We did a huge improvement. The customer will definitely be happy. And I will call them and let them know.
Great. So we are now done with the demo.
Yeah, thank you again. And I hope everyone enjoyed it. And now we are going to present our top 10 tips to speed up your site. Some of them were part of the demo. Some of them were not. And with that, I hand it over again to Francisco.
Okay, so before we start with the recommendation, let me do a quick explanation, okay? For each slide that you are going to see, for each recommendation, you will see these 3 boxes on the right side of the slide. The first one, it shows if the recommendation applies to headless and or headful AEM implementations. The second one is the area to which the recommendation applies, being origin, your AEM publish and where your application is hosted, edge, we can simplify it as the CDN, and client, which is the user browser or the mobile application. The last box, vitals metric, where the recommendation has an impact. So let's do a quick recap. LCP stands for largest contentful paint. And this is basically how fast critical content loads. FID stands for first input delay, so when the page is interactive. And CLS, cumulative layout shift, is about visual stability. And with that, let's go through the top 10 tips. Okay, ensure all your front-end code loaded is needed. It may seem obvious, but this is actually a real issue in several websites. They are loading some front-end code that is not needed at all. Typical examples in headful implementations of AEM are jQuery. By accident, you include a dependency to the jQuery client lib, and it is loaded on the website even if you don't need it. Or Context Hub. You might be loading the full Context Hub in all pages, and maybe you just need it in 2 pages. For instance, my account page or my shopping cart or the shopping cart page. Or maybe, with the Context Hub, there are several stores available out of the box, and you just need few of them, and you are loading all of them. So all of this is adding load and impacting the performance of your website. And we saw it in the demo. The app was loading jQuery, but not using it. Next one, this is about serving images with the appropriate dimensions, and next generation format. In this way, we reduce the volume of byte transfer and improve the page load. How can we implement this in AEM? So if you are in AEM 6.5, you need to leverage dynamic media with smart imaging or some other external service which transform AEM images into the next generation format and hopefully serves them from a CDN. If you are in AEM Cloud Service and you are running a headless implementation, as of now, I mean today or tomorrow, you need to do it the same as AEM 6.5. So dynamic media and smart imaging. And this is what we did in the demo. But very soon, you will get in the GraphQL response from AEM, a URL to display each image directly from the AEM Cloud Service CDN. If you are in Cloud Service in headful implementation, then just configure core components to use Web Optimized Delivery. This is just a checkbox in the content policy that you can see down there in the slide. Okay, use persistent GraphQL queries. Since the focus of this year's developers' life is headless, this is a recommendation that applies just to headless AEM implementations. Use persistent GraphQL queries. Why? Because they are faster, more secure, and the response can be cached. And with that, what do? We improve response time, and you have seen this in the demo. Talking about the cacheability of the GraphQL persisted query response, I guess you are all familiar with the GraphQL editor in AM. It is available out of the box in AM Cloud Service and as an external package in AM6.5 Service Pack 13 and over. In this editor, you can create your persisted queries, test them, and if you need it, you can also tune the cache control header for each query. The one that you are seeing there in the slide at the bottom, this is the default cache control header for persisted queries. And normally this is good enough for most of the use cases. Load JavaScript asynchronously, number 4. When your site is loading a JavaScript that is not needed to render the critical content, just load it asynchronously, using the async or defer attributes of the script tag. In this way, we avoid loading resources that block the rendering, allowing the browser to focus on important stuff. The usual suspects here are the MarTech scripts. MarTech stands for marketing technology and includes things like tag management scripts, analytics scripts, or experimentation. If you remember in the demo, we changed the AAP data collection script from synchronous to asynchronous. Number 5, getting back to the images topic, it is important to load them in an efficient way. This means preload or load with high importance the images that are part of the initial viewport above the fold, and lazy load the ones that are below the fold. In this way, we improve the load time of the critical content of the page. How can you do it in AM? Well, if you are in headless, you need to do it yourself because the application is yours, right? If you are in headful, you can use Core Components v3. They already provide some ways to control which images to load with higher priority. If you remember in the demo, we loaded with high priority just the first images, and the other was the ones in a lazy way. Fonts, well, this is a complex topic, okay? Fonts are critical because they are required to display any content. And unfortunately, there is no perfect solution for this. But there are some tips that you may use to improve the impact they have in the performance. First recommendation is host the fonts in your app. They will be cached and served from the same origin that will make the load time faster. If you can't because of licensing issues, at least host the CSS file that loads the fonts instead of, for instance, calling the Google Fonts API JavaScript, which is an expensive request. You remember we did that as well. Next tip, use font display optional if you can afford it. Why? Because this setting, what is making is telling the browser to load the fonts only if they are available when they are needed. Most of the times it means they are only loaded if they are in the browser cache. If they are not available, the browser will load a fallback font and will never replace it. Sometimes this is a minor issue, but for instance, if you have icons in your fonts or you have a very special custom font, then it won't work. If you can do font display optional, then what you could do is preload the fonts in the head of the page. They will be downloaded in background and use font display swap. This is what we did in the demo, if you remember. Sometimes the preload is not fast enough, so browser will use again a fallback font to do the first rendering and then swap the fonts as soon as they are downloaded. Be aware that if the fallback font and your custom font are very different, it might impact your cumulative layout shift. In any case, it is crucial to find the best fallback font possible. It means the one that is more similar to the one that your custom one. And there is a great Chrome extension written by my colleague Alex Kapt that helps you finding the best possible fallback font for each font. And you can find the link there in this GitHub. I invite you to take a look at it and to test it and provide your feedback. As I said, fonts is a very complex topic, and if you want to dig deeper, there is an excellent article about it, and the link is this one at the end of the slide. Number 7, defer non-critical CSS. Continuing with what we discussed about images and fonts, loading CSS should also be considered for the performance of your site. And the idea is the same. Try to load only required to render the critical part of the page and load the rest on demand or asynchronously. If you remember, in the demo, we passed from a single global CSS file to a CSS for each component. How to load a CSS asynchronously? Well, you have this snippet, this code snippet here, and as you can see, it's a bit tricky. We don't have time to go into the details of how it works, but if you want to know it, I suggest you that you check the link at the bottom of the page. Number 8, ensure user agent is not part of body header. Body header by user agent was for dispatcher configuration in the AEM project archetype. This setting, in practice, is adding the user agent header to the CDN cache key, fragmenting the CDN and therefore reducing the cache hit ratio. So please check if your project has this setting and remove it. Number 9, cache control header for assets. Similar to the previous one, until May this year, AEM assets were not cached by default at the CDN. They were served from the AEM Cloud Blob storages, but not cached at the CDN. You needed to enable it manually by adding the Cloud Manager variable AEM Blob enable caching headers. New programs created after May 22, with program number higher than 65,000, do cache assets by default. If your AEM Cloud Service program is older than this, please add that variable. And finally, number 10, ensure your site is delivered with HTTP2. There are different advantages of HTTP2 over HTTP1 in terms of performance, but if I will need to select one, I will choose multiplexing, which is the capacity of reusing a single TCP connection to perform different concurrent HTTP requests. I think the diagram below is very descriptive. You see that with a single TCP connection in HTTP2, you can also actually get all these different resources without needing to open new more. Why are we mentioning this? Because even if AEM Cloud Service CDN uses HTTP2 by default, we have seen some customers who have their own CDN or web application firewall in front of AEM, which for some reason is not properly configured and delivers the website with HTTP1. So please, if you have your own CDN or web application firewall, ensure it is properly configured to leverage HTTP2. And with this, we finish the top 10 tips, and I hand it over back to my colleague, Tobias.
Hey, thank you. So let's recap. In this session, you have learned speed matters, and AEM gives you the right tools to improve performance based on your use case. You learned about Core Web Vitals and how to optimize for them, and you learned about the top 10 recommendations on how you speed up your site. We have a few call to action items for you. So do you actually know the state of your site's Core Web Vitals? If not, I would like to invite you to run the tool against it. If you are below the magic threshold of 95, I definitely invite you to follow the recommendation as well as starting using real user monitoring. And in case of AEM head full, try out experience audit testing in the Cloud Manager pipeline. Thank you very much for attending. That's it from our side.
Thank you very much. Thank you very much for your attention, and I hope you enjoyed this session. Bye-bye.